Hello there, this is Milo with a tutorial for the Dynamic Shadow system, which you have seen in a demo video a couple months ago. So, I am going to jump right into this. First, I'm going to go over all the code and the features, and then, in the end of the video, I'm going to tell you all the notes and important aspects that you need to know to use this system. They're basically arbitrary notes that you need to be aware of, nothing too complicated. Okay, so I'm going to include a single object in the download link in the description, and that's all you need. You download that object, you right-click on the object, add existing object, and you're gonna get that object in there. Okay, so I'm going to compile the room and show you what the code does. But right before that, I gotta shamelessly cross-promote the game that I'm working on. This is a this is a platformer with a co-op feature, and the game's supposed to be very rage-inducing, so please subscribe so I can actually grow the audience to present this game for. Alrighty, shameless cross-promotion done, and I'm going to now compile the actual Shadow tutorial. Alrighty. Okay, so what you get is you have a code which traces the edges of objects, and by the end of the code process, you get 4 points, 4 XY coordinates from which you can make a shadow. So we have point 1, point 2, point 3, and point 4. You use 2 draw triangle functions, and you add the points to draw the triangle from. So you go 1, 2, 3 and connect it back, that will be your first triangle, and then 1, 2, 3 and connect it back, that will be a second triangle, and you get like 2 halves of a polygon that will create your shadow, and then you draw that shadow to your surface. At this point, this tutorial only showcases the tracing method. And since you have the 4 coordinates, I would assume that you know how to use those coordinates. But if not, I can make an actual tutorial with all the surfaces and all that stuff. But, you know, that's for users who really don't know how to use surfaces. In fact, if you don't know how to use surfaces, you shouldn't be watching this video. But anyways, closing down the demo, jumping into the object, which you should have loaded in GameMaker by now if you're following this. Create event has all these setup variables. We have sh_on, which is the variable which you can use to turn shadows on and off. You could make it global variable, but make sure you go through the code and change every other instance of this variable to global, or insert global dot before it. Light radius, this is the radius of your light, which you've seen the giant black circle around the object. And PL1 equals, this is the name of the object from which the light is supposed to be traced, or the one that's supposed to be casting the light from which the shadows are created. Now, first note is that unless you actually program, if you have multiple instances of this object, only the first instance will be creating the shadows. If you want to have multiple instances of this object to create shadows, you're gonna have to fiddle around with the code, and instead of just taking the position of any of these objects, you're gonna have to pick the closest one. This way you can have several of them. But there's important notes which you need to know in the end of the video. PLX1, PLX2, this is the tracking of this object. PLX old, PLY old, these 2 variables are initiated so that we could track if the player has moved, because every time the player with this object moves, you have to make new shadows, obviously. Direct mod 1 and 2, this is for tracking the edges. Trace 1, 2, 3, 4, these are the conditions, true-false conditions that will help us break out of the loop, which instantly traces the edges. Extender. Okay, so this is an important one. What you need to have is an extender is the extra space, which compensates when you're really up close to an object. And I will demonstrate that to you right now. Say we are up close to this object right here, we have two variables. One is light radius and one is the extender. Light radius is the radius of this circle right here, right? It says if the object is within light radius, the light will be, the shadow casting system will start functioning. It will be enabled. And the extender is this extra space, which compensates when you're really up close to an object and the shadow gets really wide. And this is what happens when the extender is not as big. It's not long enough to compensate. What you're gonna get is when you're using a surface, everything outside the circle is black, right? And this will be your light sprite, which you're subtracting from surface. But when you're getting really up close to this object, as you can see, the shadow is cutting, like this would be the end of the shadow. It's cutting through. So this is why we have that extender variable that compensates for that. Okay, and we have our basic variable points for 3 and 4. We don't really need to have to create those variables for 1 and 2, so they're created automatically. Now, in the draw event, we're just drawing all of our points and lines, which you saw in the demo. So these are just for debugging and just looking at the pretty shapes. And then the step event has all the magic. Okay, so I'm gonna go over quickly how this works. This piece of code right here, it's optional. Essentially, if you're actually using blocks to have shadows over them, I've made this piece of code that I was using it. It says the shadow will only be enabled if it has this particular object over it, and I've been using that object. The object is invisible, but I've been placing it in the room editor as kind of like an extra tool, which would basically tell the objects which ones will have the light, the shadows on them. Okay. So let's start this right away. We constantly track the position of the light source of the lantern. This is the variable that determines whether there should even be lights. Then we check the distance of an object that's supposed to have a shadow on it to a source of the light, and if it's within a range, which is light range or light radius variable in the creation code, light red. If it's true, it sets the in light to true. I could technically just have this condition enable the shadow, but I like to have it under one variable. I'm just really picky like that. Now, when in light is true, we're gonna start tracing our light. Now this is how the system works. Right now we use while loops, and while loops, as you know, they stop the entire script of the game and the script goes into a loop, and it does a certain amount of functions and equations until it reaches a condition that breaks itself out of the loop. So that being said, it says while trace1 equals true, it's gonna go through all these equations, and for visual purposes, here's what I'm gonna do. I'm gonna change while loops to if statement. So it's gonna do the exact same thing, except it's gonna do it very slowly so that you can see. And that's the difference between if statements and while loops. While loops are basically if statements, but they're really instantaneous. Okay. So as you can see, what happens first is when the object enters the light radius, first we locate the center of the object. Then as soon as technically when the player stops moving, in this case with the if statement, if the player starts moving, it's gonna start calculating. But with the while statement, it will start calculating whenever the position has changed. So we stopped moving. There we go. First thing is the two lines, they're draw lines, but you cannot actually, we're actually using collision lines. First they move out. As you can see, you move outside of the object, or they move from the center and they locate the nearest edge. As soon as the collision returns false, which means it's outside of that object, it returns false. After that, we have point 1 and point 2. After that, it shoots out 2 points from the center of the light source, and it slowly moves towards that object until it hits a collision point, until it collides with the edge. So as you can see, the 2 lines have stopped, and this is it. You now have your 4 points, x, y, point 1, point 2, point 3, and point 4. If we take a look at this again, start from here, for example, like a nice extreme right there. So we stopped. The lines start crossing left and right. They're trying to find the edge. As you can see, point 1, there's the edge 1, and there's the edge 2. As soon as that's done, it's shooting the 2 objects out of itself again. And as soon as that hits the edge, it found point 3 and point 4. So there you go. Now this is instantaneous with the loop. So I'm gonna change that to while again. In the code wise, this is what happens. Trace 1 is equals to true. And it is true when the object is created, and it's also true when the player has moved. So trace 1 is equals to true. Then it says the direction is from calculated from center of the light source to the center of the object that's being tracked. And then we need to find point 1x and point 1y, and we use a function called length direction, and it takes a direction and takes a length variable to calculate the position relative to like an angle, as you can see from the help tutorial. It takes the length and takes the angle, and you get the XY coordinates. So what it does is it points it directly in the middle of an object that's supposed to have the race cast to it. So we're using the length is the radius plus the extender. You remember that, the extender that I mentioned. And the direction is a direction from center of the light source to the center of the object. But we also have this variable here, which is a modifier, and the modifier gradually adds 0.1 point to the radius of that of the line, the collision line, and basically it's gonna keep doing that. It's gonna draw the line. And it's going to add +1 to the radius, so it's going to start slowly moving to the left or slowly moving to the right. Now what happens here is it's going to do it for as long as trace 1 is equals to true. So we need to check that line. We use PLX and PLY, which is the center of the light source, and then we use the points that we're calculating here to check if there's a collision with an object. Right? We're using ID so that whichever object runs this code, it will check against its own ID and not just any other object. That's important. Precision is true, so you can have a precise collision mask on the object, and do not check itself. If this line, basically, if this line moves outside of an object, it says, if the collision is no longer true, so the line is indeed no longer colliding with an object, it will say trace 1 to false. So this trace 1 to false will effectively break out the loop. So that's important. You need to break out of the loop. After that, it's going to say trace 1 is equal false. So this will say trace 1 is equals false, and trace 3 is equals to true. And since that is true, it's going to create the point, and it's going to use the same coordinates. And it's gonna instead of modifying the radius, it's now gonna modify the length, and it's gonna move a collision circle from the origin, from the player or from the light source towards the collision object, and it's gonna move it +1 pixel, just like before. And as soon as the collision, in this case, as soon as it collides with an object, so it found that early edge or the first edge. It's going to set it to true. So this is the first side, and exactly the same code, just, you know, instead of point 1 and point 2, it's point 3 and point 4. And as soon as that happens, you got your left side and your right side, and you have your points. So now you have your 0.1x, 0.1y, 0.2x, 0.2y, 0.3x, 0.3y, and 0.4x, 0.4y. You got your 4 points to make the shadow from. Now, what happens when the player moves? We have the variables plx and ply, and we have plx old and ply old. And we say if the player moves and his old coordinates, either x or y, if they're not equal to the current coordinates, it's going to reset all the statements for the tracing. It's going to reset all the modifiers, like the direct modifier and the moving modifier, so that we can start the tracing from the beginning. And it's going to reset, or it's going to once again re-record the position of the player into, you know, the old variables, so that, you know, as you said, so that this wouldn't be repeating itself in like a its own loop, so that, you know, it wouldn't constantly reset these values, and thus, you know, this entire thing would be void. So as you saw here in the draw event, all we have is, you know, draw lines and circles, just so that you could see the visual representation of how the code works. Oh god, please tell me, did I change that to while loops? Yes, I did change the while loops. Okay, perfect. I'm not an idiot. Not yet. Okay, so you see there's a line there. It's because I've placed the shadow object right outside, and it's kind of hitting the edge. If you're looking right here, there's that object right there. Okay, so as you can see, you get 4 points. Now, how do you make this into a shadow? Well, usually you'd have to use a surface. And you take whatever's supposed to be a light, and you make the surface black, and whatever's supposed to be a flashlight, you puncture the surface with the flashlight with the subtract blending mode. But with this, with the shadow, you would instead add the blending mode back, so that the shadow, the surface would reappear where the shadow's supposed to be. And, you know, you would add it like the alpha, so that it wouldn't be totally black again. Okay, so how can you use the 4 points to make a shadow shape, right? At this tutorial, I'm not going to be doing the surface. I may do that in the next tutorial and explain how it's supposed to be done, how it's supposed to work. And there's a number of things that I had to discover for myself when I was making my own shadow system. In my own game, because I've been using views, and when you use views, there's a lot of finicky stuff that's going on. Anyways, so I'm gonna comment all this stuff out. Comment it out. And so how to use those points? Well, you need to use triangles to make a polygon, and a polygon is it's a square with usually, technically, it's a triangulated polygon is 2 triangles. Right? And that's in 3D, use polygons. So in this case, you need to make 2 triangles into a square, because GameMaker does not have an actual draw square tool that allows you to have 4 points defined. So draw triangle. So normally you would do this not in this object, but you would do this in your surface, right? If you know how to work with surfaces. So draw triangle, and first you'd have to use, let's see, I'm just gonna copy and paste it because I don't want to have any debugging error messages. So 0.1x, 0.1y, then we need to have 0.2x, 0.2y, and then we're gonna get 0.3x and 0.3y, and obviously, you know, the function asks if we want to have an outline, and say no. No. Okay. Now we have 1/2 of that. Now we need to copy that, and we need to have we need to start. We have 0.1x, 0.1y, 2, 3. We need to start from 0.2, then 0.3, and 0.4. Now, it's very important that this also is also contained inside of the condition that the object is located within the radius. As you can see, we're using the same condition in the step event right here. If point distance, you know, plx, ply, if it's within the light radius, because these variables are only defined when they are inside of the object, when they are inside of the light radius. Because as you remember, in the create event, we've only defined PLX 3 or 0.3 and 0.4, right? The XY coordinates for 3 and 4. So that means that if we would have drawn the code from outside of that condition, only within that, if that condition is true, we get point 1 and 2. We get an error message. Whoops, I'm sorry. I have selected Android for render somehow. Okay. Alrighty, come on. Come on, Game Maker. Keep up with me. Okay. So here's what's gonna happen. We get an error message because it's not finding that point 2 coordinates, because we did not define them. They're only created when this code comes through, and this code comes through only when the object is within the range. You could define it. You could go in here and put in, 0.1, 0.2 x, y, and set them to 0, but it works without it. So keep it to whatever you want. So we'll put that back inside of the condition, so it will only draw the triangles, and it will only ask for these values when the player is within the range. And when the player is within the range, it will create those values. So once that happens, we of course going to compile. And when we compile, as you can see, we got our shadow. And first thing off, this shadow has to be either used alone, or it has to be used with the surface, because first thing is when you have a bunch of objects sitting together, you get overlapping shadows. So you have to use surfaces to get the shadows to behave properly with each other, unless you're making a very creative game, and you have like your own idea of how to use that. So anyways, we have our shadow. It is done. You can now usually, instead of drawing them directly on the object, you would draw them to the surface, and you do the subtract, blending mode, yada yada yada. So this concludes the tutorial. If you have any questions, post them on the video comment section.